Today we're going to be looking at some demos that revolve around mixtures, pure substances, and compounds. So make sure you have your worksheet out in front of you so you can follow along as we go. Our first combination of substances is sand and water. So we're just going to add a little bit of sand and water to our beaker here. And we'll give it a little stir to get it all mixed up. Now, one of the first things that they want you to do here on the worksheet is just to sketch a little picture of the beaker of sand and water. And then we're going to go through and we're going to describe some of the properties of sand and water. So some of the properties of our combination here is that it's brown in color. We can tell that the water is still liquid, but the sand is still a solid. And the sand is starting to settle out of the water. In fact, if we were to leave that beaker for long enough, it would look like the other beaker that I just sat down, where almost all of the sand has settled out of it. Sand and water is in fact an example of a mixture. The next thing we want to think about is how can we separate this mixture of sand and water? Now, sand and water is pretty easy to separate because you can do it by a process called filtration, where here I'm setting up a little flask, and in the flask I am putting a funnel with a little bit of paper towel to act as some filter paper. Now that the filter paper is in the funnel, we are going to just pour our mixture of sand and water through it, and all of the sand is going to get caught in the paper towel, while the water will slowly drip through it and end up in the flask. And then our mixture will be successfully separated. Now you'll want to turn the page to the second page of your worksheet because we're going to look at our next combination of substances. So here on the table again, I have another beaker of water. Now to our beaker of water, we're going to add some salt. And once we've added a decent amount of salt, we're going to stir to dissolve the salt. And again, the first thing that your worksheet wants you to do is to just sketch a picture of the beaker of salt and water. And one of the first things we should notice with regards to properties, because we're going to describe the properties again, is that this time our combination of substances is perfectly clear. You also can't see any of the salt. It's all dissolved. And another property that we probably know from prior experience is that if you put salt in water, it's going to taste salty. Salt and water is also another example of a mixture. The next thing we need to think about is how we might be able to separate a mixture of salt and water. It might not be obvious at first, but if we were to take this beaker of salt water and put it on a hot plate and boil it, we would be able to boil all of the water away and be left with just the salt. Here we can see an example of what it looks like once you've boiled all of the water away from the beaker of salt water. That white crust that you see at the bottom is the crystallized salt that's left after all the water has become steam. Let's turn the page again in our worksheet so that we can talk about our next set of substances. In these two test tubes, I have two different substances. The test tube labeled with a W contains water, and the test tube labeled with EA contains ethyl alcohol, also known as ethanol. Water and ethyl alcohol are both examples of pure substances. A pure substance meaning that in the water test tube there are only water molecules, nothing else. And in the ethyl alcohol test tube, there are only molecules of ethyl alcohol and nothing else. So now what we want to do is we want to compare the properties of these two pure substances. So we've got a whole list that we're going to look at. First of all, appearance. Appearance is pretty simple. Both water and ethyl alcohol are clear. Odor. We should all know that water usually has no odor. If you were here in the class, you would be able to smell that ethyl alcohol has a very strong odor, similar to rubbing alcohol. Next up for properties is flammability. Water is of course not flammable, that's why we use it to put out fires. Ethanol, on the other hand, we will do a little test with. So now I'm going to put a small amount of ethanol on the table, and we're going to turn out the lights, and we can see that it is indeed flammable, and it tends to burn with a rather large orange flame. But eventually it goes out. And when we look at the table in the light again, we can see almost all of the liquid is completely gone from the table. Our next property is density, where the density of water is 1.0 grams per milliliter, and the density of ethyl alcohol is 0.79 grams per milliliter. Then we have a melting point. The melting point of water is just 0 degrees Celsius, while the melting point of ethyl alcohol is negative 114 degrees Celsius. The boiling point of water is 100 degrees Celsius, while the boiling point of ethyl alcohol is only 78 degrees Celsius. The last property on our list is solubility. Solubility is just basically how good is a liquid at dissolving something. And we're going to be testing the solubility of sugar in these two pure substances. So what I'm going to do now is I'm going to put a sugar cube in both the test tube of water and the test tube of ethyl alcohol. And we're going to kind of observe what happens to the sugar over time. Now to make this go a little faster, we're going to show the video at about 8 times speed. When we zoom in here, we can clearly see the sugar cube in the water losing its shape, little bubbles are coming up, and it is definitely dissolving, which is what we would expect to happen. But in the ethyl alcohol, absolutely nothing is changing about that sugar cube. So we'd say that sugar is soluble in water, but it is not soluble in ethyl alcohol. So now we're going to look at a mixture of water and ethyl alcohol, and we're going to kind of compare the properties of the mixture to the properties of the two pure substances. So in the test tube I have some water, and now I'm adding a roughly equal amount of ethyl alcohol to the test tube. And we're going to give it a little bit of a stir to make sure it's good and mixed. And what you'll see is that its appearance is rather cloudy. And if you were here in the classroom and able to smell it, you would find that it has an odor, but a weaker odor than the ethyl alcohol does. The next property, of course, to look at is flammability. Is our mixture flammable? So I'm going to put a little bit of our mixture here on the table, and just like last time, we're going to see if it will ignite with our little lighter here. and we find that it is flammable, although the flame seems much smaller and more blue than it is orange. It does seem like the flame stays lit for a little bit longer, even though it's small, though. When we turn the lights back on, we see that there is liquid still left on the table, which likely means that the ethyl alcohol burned away and water is left on the table. The next property that we want to look at is density. The density of the mixture is likely about 0.9, right in between the density of the two other substances. Melting point would be a hard one to test because we can't get it cold enough to deal with ethanol. But we could test for the boiling point of the mixture by doing a distillation. So what I'm going to show you next is the temperature time data for that distillation. So here we can see the graph of temperature versus time for the mixture of ethyl alcohol and water, and they start at about 27 degrees Celsius room temperature, and temperature goes up quite a bit, and then it seems to level off a little above 80 here, and then temperature drops and goes up again and levels off again at about 100. So this is a little bit unusual because we're seeing two plateaus, 2 points where a phase change appears to be taking place. So what's really happening is that the ethanol, the ethyl alcohol, and the water are boiling separately. So the mixture first reaches the boiling point for the ethyl alcohol, and all of it vaporizes and boils off. Then temperature is able to rise again until it reaches the boiling point of water, where the water starts to boil. So the last thing we have to do is test for the solubility of sugar in our mixture here. So I've dropped a sugar cube into our mixture. It's a little bit hard to see because of the cloudiness, but we're going to zoom in and see what we can manage to observe. Again, we've sped up the film here to about 8 times speed. And again, it's really hard to see in the video, but if you were in the classroom, you'd be able to tell that the sugar cube is dissolving ever so slightly in the mixture, but not nearly as much as it dissolved in the water. So in the mixture, we would say that sugar is somewhat soluble. So now let's turn to the last page in our worksheet so we can examine some of the differences between a mixture and a compound of iron and sulfur. And we're going to be looking at an older video and pausing it to kind of make some observations.
In this experiment, we will first make a mixture of black iron filings and yellow sulfur powder. Black iron filings and yellow sulfur powder are thoroughly mixed. They form a gray mixture of the two elements. This mixture can be separated by physical methods. For example, when a magnet is brought to the mixture, it removes essentially all the iron filings, leaving the sulfur behind, which here looks gray because of the impurities from the iron. The iron has been separated from the sulfur by means of a magnet. When the same mixture is heated in a test tube, the two elements iron and sulfur react together to form a new compound, iron sulfide. At first, when the mixture is heated, the sulfur melts. Eventually, as the heating continues, the iron and sulfur begin to react together. When the Bunsen is removed, the tube continues to glow as the reaction proceeds. The gray-black, brittle solid formed is a new compound, iron sulfide. It is unlike either sulfur or iron and cannot be separated by a magnet.
Now you should have all of your worksheet filled out with the exception of those last two questions, which I want you to try on your own.